Okay, so here is your Chapter 3 test review for exponential and logarithmic equations. Alright, so you recently opened a new bank account and placed $950 into the account as a starting deposit. If your bank account compounds weekly at a rate of 26.3%, how much money would be in there after 6 years? So I gave you the equation, so let's just start plugging in our numbers. Well, P is your starting amount, and our starting amount is 950. So A equals 950 times 1 plus, now remember, this is R, but you have to convert it to a decimal. So you got to move this over. So 0.263 divided by n, which is your number of compoundings per year. Since that's weekly, it's 52 raised to nt. So 52 times 6. All right. So now you plug this into your calculator. And remember, it is this raised to 52 times 6 times 950. Not all of this, not 950 times this raised to 52 times 6. All right. So the 1 plus 0.263 over 52 raised to 52 times 6 will give us 4.826, and it'll be that times 950, which is $4,584.72. All right, so that's how much money you're going to have after 6 years. Pretty good amount. All right, so number 2, you stumbled upon the worst kind of credit card possible. Credit card compounds interest continuously, so we're going to use this formula. If you charge $700 on this credit card and this is your interest rate, how much will you have after 11 years? Now, so what we're going to do is A equals P, which is our principal, which is $700, times E raised to our rate. Now, 8.4%, but as a decimal, you got to move it over 2 places. So as a decimal, it is 0.084 times time, which is 11 years. Because remember, in these equations, your t has to be in years. All right, so E raised to 0.804 times 11 will give you 251.9, or 2.519, sorry. And you take that, multiply it by 700, and you get 1763.54. Now, you might be wondering why when I ask you to round, I say 3 decimal places, but here I'm only rounding to 2. It's because this is money. All right, money wouldn't make sense to round to anything other than 2 decimal places. All right, so there's the first 2. Let me clear this and move on. Number 3, in an incredibly tragic, yet not entirely unexpected, incident, an asteroid has passed too closely to the Earth in 2012, radiating radioactive, blah, 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 turning people into zombies. All right, so it says, assume that the first place on Earth infected was Lakeland. Yeah, that'd be our luck. Originally, there were 21 people turned into zombies. Approximately 58.4 minutes later, there were 67. How many will there be after 5.7 hours? Now, remember, this t can be in any unit you want. So let's make it minutes. Okay? Let's make it minutes. So, y is going to be 67, because here we have to solve for k because we don't have the growth constant. So we have to find k. All right, so we have 21 initial zombies. All right, e raised to k, which we don't have, times 58.4, and we know that all of this is going to equal those 67 zombies. All right, because approximately 58.4 minutes later, there were 67. So we have to solve this for k. So divide both sides by 21. And yes, I would recommend doing it this way. 67 over 21 equals e raised to 58.4k. Now to get rid of the e, take the natural log of both sides. That cancels that out. So you have the natural log of 67 over 21 equals 58.4k. Divide both sides by 58.4. So k equals the natural log of 67 over 21 divided by 58.4. You can type all of this into your calculator as is, and that's what I would recommend doing, because that way you don't have to round and you can still get the correct answer. All right, so k, I'm going to write it up here because I'm going to erase all the rest of this, rounded to 3 decimals, or 3 significant figures, is 0.199. Now, what I would suggest doing on a calculator is storing that value as k. All right, storing that value as k. So then when you go back, you can use the entire decimal place because it does actually change the answer pretty significantly. All right, so let me get rid of this now, so I don't have any other room to write. Now let's find out how many they're going to be after 5.7 hours. So now we don't know y. So this is 21 because it's still our initial amount, all right, equals e raised to k 0.0199 times 5.7 hours. Now, I realize I said that this can be any units, t can, but you have to stay consistent. Since we started in minutes, we need to end in minutes. So we need to convert this to minutes. How do we do that? There's 60 minutes in an hour, so just multiply that number by 60. You get 342. All right. Now what we can do is we can punch this all in the calculator and use k for this now because we saved it in the calculator. If you ask me tomorrow, I can help you save it. I won't tell you necessarily if your answer is right or wrong, but if you're like, hey, Mr. Relation, can you help me store this as a variable? I'll be like, sure, here's how you do it. But I'm not going to tell you if your answer is right or wrong. All right, so after you punch all this in, you should get 18,744.764 zombies. How do you get partial of a zombie? Well, he's missing an arm or a leg or something. In this case, he's missing 3/4 of them, so he's missing a lot. He's like a torso zombie. All right, so that's how you do that one. After you find k, it's pretty simple. It's just plug and chug, as I like to call it. You just plug in all your values and chug along till you get the answer. All right, moving right along. Find the following log value. Now, I realize the TI Inspire will do this for you, but what I'd like you to do is actually use change of base. So this will be the log base 10 of 3.2 over the log base 10 of 3. Or you could say the natural log of 3.2 over the natural log of 3. Both will give you the same answer. All right, so the natural log of 3.2 divided by the natural log of 3, because like I said, they'll both give the same exact answer. It is 1.059. All right, same thing here, change of base. So it's the natural log of 6.96 divided by the natural log of 3. So you just simply punch that into the calculator, and the calculator will give you the answer, 6.96 divided by the natural log of 3, and you get 1.766. All right, so those are pretty simple. Now, condense the following expression involving multiple logarithms into a single. What I would do is this negative 9 log 7 of y, take it, throw it on the end. Because then you have 4 log base 7 of x plus 5 log base 7 of w minus 9 log base 7 of y. Now, pick up all your exponents. So this would be 4, 5, 9. Now these you would add together. Since they're addition, they'd be multiplied. Since this is subtraction, it is division. So you can condense these first and then do this one, or if you realize that this one is going to be on the bottom, so I can draw like a little fraction bar. This is going to be on top, this is going to be on the bottom. So the answer, I'm going to write it over here, is going to be the log base 7 of x to the 4th, w to the 5th, over y to the 9th. That's your answer. All right. Now, number 7, e raised to 2.7x equals 13.22. For this one, you're going to have to take the natural log of both sides, because that cancels out the e, bringing the exponent down. So it's going to be 2.7x equals the natural log of 13.22. Divide both sides by 2.7. So x equals the natural log 13.22 divided by 2.7. That gives us 0.956. All right, so let's look at this next one. Natural log of 9x equals 4.09. Well, here, remember you got to use that big E, because remember the base of this is E. So you use the big E, and that cancels that out and drops the 9x down. So 9x equals E raised to 4.09. Divide both sides by 9. So x equals E raised to 4.09 divided by 9. So it is 6.638, rounded to 3 decimal places. All right. Here, since this is an 8, you're going to take the log base 8 of both sides. Gives the log base 8 and that cancel out, leaving you with 3x equals log base 8 of 30. Divide both sides by 3. Ignore the announcements. Now, this is not the log base 8 of 10 because the 30 and the 3 were reduced to 10. It's the log base 8 of 30 divided by 3. All right, so now take the log base 8 of 30 and then divide that by 3. And that will give you 0.545. Now, this one looks hard, but it's really not. Since this is base 2, you're going to do a big 2. All right, so that cancels, leaving you with 5x plus 6 equals 2 raised to 3.75. Subtract 6, subtract 6. So 5x equals 2 raised to 3.75 minus 6. Divide both sides by 5. So x equals 2 raised to 3.75 minus 6, all divided by 5. So x is 1.491. All right, so that's your test review. Hopefully you got all these right. If not, I gave you the answer key on the back of your test. I mean, well, your test review. It won't be on the back of the test, of course. So hopefully you got them right. If not, see if you can figure out what you did wrong and learn from it. All right, see you tomorrow. Hopefully you're ready.